2019. 2019, yeah. All right, so number one, expressed in the form a plus bi, where a is that, so we had to rationalize this. I'm gonna zoom out one, should be able to see that still. So we get in, I'm not gonna put minus 2 plus 2i. I'm gonna put 2i minus 2 just to make my life visually easier, over 1 plus I. And I multiply by 1 minus I over 1 minus I. Now we know that how, based on the last year's paper that we did, 2018, 1 minus I by 1 plus I on the denominator, that working out to 1 minus I squared, which is 1 minus minus 1, which is going to give me 2 on the denominator. So let me see what the numerator works out to be. I'm going to get 2i multiply 2i minus 2 by 1, which is 2i minus 2, and then 2i minus 2 multiplied by minus I, which is minus 2i squared plus minus plus 2i. Cool. So 2i plus 2i is 4i, minus 2i squared is going to be minus 2 into minus 1, which is positive 2. Minus 2 plus 2 is 0, so 4i over 2. And I'm going to get just 2i. So number 1, D is the answer. The quadratic equation with roots 2 plus or minus I root 3 is, so let me see what the sum of the roots is. So we have 2 plus I root 3 plus 2 minus I root 3. 2 and 2 is 4. So we know that how it's x squared, take away the sum of the roots plus the product of the roots. What is 2 plus I root 3 multiplied by 2 minus I root 3? It's a difference of 2 squares. Is the first thing squared, which is 4. Take away the second thing squared, which is I squared by 3. So it could be 4 plus 3, which is 7. So x squared minus 4x plus 7. X squared minus 4x plus 7, the answer is C. The modulus of the complex number, square the first, square the last, and then square root everything. So we have a quarter plus a quarter, that is a half, and we had a square root that, so 1 over root 2. Answer is B. The value of this to the power 4 using the Moivre's theorem, it could be cosine pi plus I sine pi. So cosine pi is going to give us minus 1. Sine pi is going to give us 0. So the answer for this is B. If z is equal to that, the locus of the point xy, we know the radius had to be 3. So it's either C or D. So let me get what the center is. So it's going to be z take away 5 minus 2i. I'll get back the minus 5 plus 2i. 5 minus 2 is going to be the center. The answer is D. Given that y is equal to tan inverse x, when I differentiate tan inverse, it's going to be f dash x, which is going to be 2, over 1 plus f of x squared, which is 4x squared. So 2 over 1 plus 4x squared, the answer for number 6 is C. Number 7, the complex number z is equal to root 3 plus I can be expressed as, so let me get r, which is the magnitude or the modulus of the complex number. Root 3 squared is 3, and 1 squared is 1, so 3 plus 1 is 4. The square root of 4 is 2. So it's either here or here. And then let's get the argument. So tan inverse of 1/3, 1 on root 3, sorry. That's going to be pi on 6. And this is in the first quadrant. So the argument is pi on 6. So the answer is B. Alright, so I'm bringing it into exponential form first, and then I'm sending it down into trigonometric form. Given that z is that, then the exponential number, this is a repeat question. All right, this is minus, yep, I believe it's repeat. So let's just entertain it just for a second. Let's see if it is indeed a repeat question. Minus 1 plus root 3i. Let's see. Wouldn't be so far up. Minus 1 plus root 3i. So it's 2e to the 2 pi on 3i. Two e to the 2 pi on 3i. So the answer is C. So I'll still go over the working for it, right? So we know that I'm not going to bother to calculate r, which is the magnitude, because all of them is 2. I'm going to calculate the argument. So we know that the reference angle, usually some books and some teachers, they say the reference angle is alpha. That's just tan inverse of root 3, which is going to be, I believe, pi on 4. And pi on 3, sorry. And because the complex number is in the second quadrant, the argument is pi minus pi on 3, which is 2 pi on 3. The derivative of the function with respect to x is, so now it have no easy way to go through this. We have no choice but to go through the full working for it, right? Give me a second. All right, so when we differentiate in ln, we need to differentiate the function. So I'll differentiate cos on sine. Cos on sine is uv, so it's going to be v du dx. Take away u dv dx all over v squared, which is, well, we could just put sine squared x. So I'm going to get minus sine squared x minus cos squared x, which is minus, open bracket, sine squared x plus cos squared x, which is minus 1 over sine squared x. And this is going to be minus cosec squared x. And then we have to divide that by the original function. So I could leave it as minus 1 over sine squared x divided by the original function, which is cos x over sine x. So I'll multiply by sine x over cos x. The sine and the sine cancel, so I'll get minus 1 over sine x cos x. 1 on sine is cosec, 1 on cos is sec. So the answer is B. And yes, there is the other way to do it as well. Cos on sine is cot. And by differentiating this, knowing what the derivatives are, the derivative of cot x is going to be cosec squared x. The derivative of cot x is negative cosec squared x, sorry. And then we have to divide by the sine x, cosec x over sine x, cos x over sine x, sorry. Alright, so if x is equal to this, the second derivative, so when I differentiate ln of 2x, that's going to be the derivative divided by the function. So I'm going to get 1 on x, and that's x to the minus 1. So when I differentiate this again, I'll get minus 1x to the minus 2, which is minus 1 over x squared. The answer is D. The integral of 1 over 1 minus sine squared x with respect to x is, well, 1 minus sine squared is cosine squared x. So I'm integrating 1 over cos squared x dx. Cos squared x is sec squared x. 1 over cos is sec. So I'm integrating are really integrating sec squared x dx, which is just tan x plus c. Next, the integral of 2x e to the minus x dx. It's no easy way to put this one. We had to go through the integration by parts. So u is equal to 2x and du is 2. dv is e to the minus x. v is minus e to the minus x. uv 2x by minus e to the minus x minus the integral of v by du, and this is going to be 2 minus 2x e to the x plus, when I integrate 2e to the minus x, I'm going to get minus 2e to the minus x. So I could just put that there and they factorized. Or I could just check and see which one expands to give me minus 2e to the minus x, minus 2x e to the x, which is this, and minus 2e to the minus x, which is this. So the answer for 12 is D. Oh, good. Given that a, b, c, and d are constants, then this can be expressed as, all right, now this have to be broken up into partial fractions, have to be. We are going to get a repeated root, and we are going to get a linear root. All right, so when I break this up, I'm going to get a over x plus b over x squared plus c over x minus 1. So which one of these given me 3 functions, and when I integrate in, I'm going to get a ln x. When I integrate b over x squared, that will be bx to the minus 2, which is minus, well, it will be bx to the minus 1 over minus 1, which is minus b over x. And I'm going to get c ln modulus of x minus 1. Now, the only thing that looking correct here is going to be the integral of that. It had to be a. Sorry, it had to be d. But my concern is for this one here, right? Minus b over x. Okay, that's fine. All right. The reason why this is fine, minus b is a constant. All right. Plus b is also a constant. So at the end of the day, if I were to talk it in terms of not just signs alone, but in terms of constants, when I integrate the question in any question, 3 over x squared into x minus 1, I'm going to get a constant by ln x plus a constant divided by x plus a constant by ln of x minus 1. For the middle piece, plus a constant divided by x. That constant could be negative. So I could have plus negative 3 over x and so on. Cool? All right, number 14. Like I said, number 14 is that repeat question, and we know that all the answer is e to the x cosine of x plus y. So I will leave it in your hands to go back into 2018 and verify that del f del x and del f del y are the same things, and the answer will indeed be e to the x cosine of x plus y. I believe number 15 is also a repeat question, but we will still go through the working. When I'm integrating tan squared x, I'm integrating sec squared x minus 1, and I put in the quarter on the outside. Sec squared x, the integral is tan x, so I'll get tan x minus x between pi and 0. My final answer, I'll just divide it by 4. So I'm going to get tan pi minus pi, take away tan 0 minus 0, or tan 0 minus 0, 0. Tan of pi is 0 minus pi, and I'm dividing everything by 4, pi on 4. Minus pi on 4, sorry. So number 15 is A. The value of the term that is independent of x in the binomial expansion of this is, alright, so we had to go through the NCR business, right? This wasn't a repeat question as well. I can't remember. Right, regardless, let me still go through the working. We know that our NCR, a to the n minus r, b to the r, I'm going to get the x coefficient alone, which is going to be x to the power 0. So we're going to get x squared to the 12 minus r multiplied by x to the minus 1 to the power of r is equal to 0. 24 minus 2r minus r is 0. And we did get r is 8, so the answer was 12C8. And we show that our 12C8 and 12C4 are the same thing when we punch it in the calculator. This one was also a repeat question. Which one converges? We're checking to see which one, as the limit tends to infinity, which one will give us a constant L. B will be the only one to give us a constant L. Our sequence is defined as u sub n plus 1 is equal to 1 minus 1 over u sub n, where u is 1 and n is a natural number. The 20th term of the sequence is, well, we had to check and see what u1, u2, u3, and so on is, see if we get AP or GP, and then calculate the 20th term, right? So the say that u1 is just 1. So u2 is 1 take away 1 over 1 plus u1, which is 1 minus a half, which is a half. Then u3 is equal to 1 take away 1 over 1 plus a half, which is, I'm going to punch this in my calculator, right? 1 take away 1 over, open brackets, 1 and a half, 1 and 1 half, again a third. Okay, if u4 is a quarter, then I know that how my u sub n is, the denominator is just going to be whatever n is, 1 over n. 1 take away 1 over 1 plus a third. So instead of 1 and a half, I'm going to have 1 and a third. And I get a quarter. So yes, u20, the 20th term, which is u20, is going to be 1 over 20. The Maclaurin series for sine x up to the term in x cubed. Now, this is one of the series that I hope that all you would have etched in all your memory by now. And if you didn't etch it in your memory, we will still go through the expansion for it. So f of x is equal to sine x. The first derivative is equal to cos x. Let me get f of 0 is equal to 0. F dash 0 is going to be 1. Then I differentiate again, I get minus sine x. And f is equal to 0. Then f cube x is equal to minus cos x. And f cube of 0 is equal to minus 1. We want the up to x cubed, right? So we know that how Maclaurin is f of 0 plus f dash x plus f squared x squared over 2 factorial plus f cubed x cubed over 3 factorial. It will be 0, right? This one gonna be f squared, so it will be f dash 0 multiplied by x, then we have x squared, then we have x cubed. All right, sorry about that. So f of 0 is 0, f dash 0 is 1, so we get an x. F squared 0 is 0, and f cubed 0 is minus x cubed over 3 factorial, 3 2s are 6. So x minus x cubed on 6, the answer is A. Number 20, this is a method of differences, and I believe this is a repeat question. So when r is 1, we're going to get 1 take away a half. Then when r is 2, we're going to get a half take away a third, and so on. The first term will survive and the last term will survive. When r is n, we're going to get 1 over n take away 1 over n plus 1. The last term survives, which is minus n plus 1. 1 minus 1 over n plus 1 is n plus 1 minus 1 over n plus 1. N over n plus 1. The answer is D. Which of the following series are arithmetic series? 7 plus 3r. That is indeed an arithmetic series, right? The second one now. 2. Well, 1 is an answer. So I just always like to do these particular types of questions using a process of elimination. So since 1 is an answer, this, and this are answers. So let me check and see if 2 is one of them as well. We gotta manually check, right? So r starts at 1. 2 multiplied by 3 to the 1. 2 multiplied by 3 squared plus 2 multiplied by 3 cubed. 6 plus 9 2s are 18 plus 27 by 2 is 54. This is not our AP. So 2 is out of the question. So that means this and this is out of the question. We had to check and see if 3 is indeed our AP. So we're going to get log of 3. Here what we're going to do. I'm going to put r plus 1 log 3. I'm going to get, when r is 1, I'm going to get 2 log 3 plus 3 log 3 plus 4 log 3 and so on. So every time I am just adding log 3 every time. 2 log 3 plus log 3 is 3 log 3. So 3 is indeed a arithmetic progression. So the answer is B. Number 22, e to the x minus 4 to the x has a root between, this is a repeat question, between 1 and 2. Right, I don't think I need to go over that. Use the intermediate value theorem. This is also a repeat question. This is a over 1 minus r, 180 over 1 minus 1/3. And I believe this worked out to be 135. Alright, so we have a sum to infinity of a method of differences here. So number 20 and number 24 is the exact same thing. Alright, so we need to see when, if I fix this up, right, this alone, 1 over I take away 1 over I plus 1 is the same thing here. And this same thing here simplifies to n over n plus 1. So I'm going to check and see what the limit as n tends to infinity of n over n plus 1 is. Divide the top by n, divide the below by n. I get 1 over 1 plus 1 over n. As n goes to infinity, That goes to 0. So I'll get 1 over 1, which is 1. The answer is C. The equation has one real positive root in the interval. The value of n is... Alright, so there's a cubic, so I could go on my calculator and solve the cubic, right? Mode 2, 3. 1 for x cubed. X squared is 0. Coefficient of x is -1 and the constant is -3. So one of the answers is 1.67. The next two answers are complex. So it has a root between 1 and 2. So n is 1, this is 2. So that means, well, n is 1. The value of n is 1. N goes from 1 to infinity. Alright, so another converging geometric question. Let me get the first two. When n is 1, I'll get 2 into a quarter to the power of 0, which is 2. That is A. Let me get the... Let me get the second term. So when n is 2, I'll get 2 into a quarter to the power 2 take away 1 is 1, which is a half. So a half divided by 2 is going to give me r. So r is going to be a quarter. A over 1 minus a quarter. 2 divided by 3/4 is 2 multiplied by 4 over 3. Nice, 8 over 3. Given that this is the repeat question, and the answer to this was, we know that when I sum in from 1 to n, this is going to be the same thing as summing from 1 to m plus summing m plus 1 to n. This is s sub n, this is s sub m. This is what I want, so I rearrange s sub n, take away s sub m. C. A continuous function is defined by the first approximation. 28 is definitely a repeat question. So just remember, for linear interpolation, it's going to be b mod f of a plus a mod f of b over mod f of a plus mod f of b. So it's your job to now plug in. This is a, this is b. 1 is f of a, negative 0.76 is f of b, so the modulus of f of b is positive 0.76. When we work out this, we will get 0.454545, and to 3 decimal places, it's going to be 0.455. 29 is also a repeat question. The answer is B, because n must be greater for NCR, n must be greater than r. Over here, n is less than, the numerator n minus 4, that's less than n, and n is less than n plus 4. So we need to get n being greater than the denominator, which is n minus 4. Oh God, Ugh. It is given that the equation has exactly one root in the interval. Jesus Christ. By performing interval bisection twice, the more accurate determination of the interval, very important, they want to know what the interval is containing the root. Alright, so our first bisection is going to be half of 0 and 1. Oh God, we had to get what f of 0 is. F of 0 is 1. F of 0 is 1. And f of 1 is... We had to work that out. Let me check and see. Alright. E to the power 0.5 plus 1 squared is 1. Take away 3.5. Negative 0.85. All right, no scene. So the first bisection is going to be half of 0 and 1, which is half. F of a half is, all right, so e to the power 0.5 by 0.5 plus equals plus 0.5 squared minus 3.5 multiplied by 0.5 negative 0.22. So our root lies between 0 and a half. So I'll have to now check the midpoint of 0 and a half. So f of 0 multiplied by f of a half is less than 0. So the second bisection is a half of 0 and a half, and they said to only perform 2, right? This is a quarter. So we have to calculate f of a quarter now. That is 0.25, so I just change the 0.5s to 0.25. So 0.25. Oh, got it. I gotta write it down again, yes? E to the power of 0.25 by 0.5 equals plus 0.25 squared equals minus 3.5 by 0.25 positive, so 0.32. So that means our root lies between a half and a quarter. F of a quarter by f of a half could be less than 0. So the interval is between a quarter and a half. The answer is D. Alright, so this one took us the most amount of time so far. Alright, so we're working on good time. We are 32 minutes in and we are number 31. Which of the following statements is true? Alright, we know one is not true because we can't just multiply a summation, take out the square from a summation and multiply it by 2. We know that our number part B is not true. We know that our part C is not true because if I adding up all of the constants from 1 to n, I'm going to get, in this case, 2n. And part D, when I am adding up from 1 to n and 0 to n, I'm going to get, if I expand the left side, 1 squared plus 2 squared plus 3 squared. When I expand the right side, 0 squared plus 1 squared plus 2 squared plus 3 squared. So the answer is D. From the letters A, B, C, D, and E, the number of 3-letter words that can be made if no letter is repeated. So a 3-letter word, so I'm picking 3 from 5, which is just 5 pick 3. So 5p3, 60. This is a repeat question, but we'll still do it again. The probability that L occurs given that K is L intersect K over K. L intersect K is 0.15 divided by K is 0.45 plus 0.15, which is 0.6. 0.25 is the answer. This is also a repeat question. The answer for this was 800, but we'll still go through it. A committee of 3 teachers, and we have 5 teachers to pick from. So 5 choose 3. 3 doctors, and we have 4 doctors to choose from. And 3 lawyers, and we have 6 lawyers to choose from. 6 choose 3. When you multiply it out, we will indeed get the 800. This is also another repeat question. Given that y is 0 at x is 0, the general solution of the differential equation is, when I solve the auxiliary equation, I'm going to get one real and equal root. So for real and equal roots, we're going to have ax plus b e to the root, which is minus 3. Minus 3 would have been the root for this. They say, well, this is y. They say that when y is 0, x is 0. So I'll just rearrange, substitute x and y inside here. So I'll get 0 is equal to b when I substitute it. B e to the power 0. B is 0. So my answer is going to be ax e to the minus 3x, where a is a constant. That constant could be represented by anything. And in this particular set of options, that constant is represented by the letter B. Given that h is non-singular, the determinant h of h is non-singular, right? Is a non-singular square matrix. The determinant, they just put in the symbol. The determinant h squared of the matrix is, now properties of determinants. Determinant of AB is the determinant of A by the determinant of B. So the determinant of h squared is going to be the determinant of h by the determinant of h, which is the determinant of h by the determinant of h, which is the determinant of h all squared, which is a relay team of 5 teachers is to be chosen from a group of 15 teachers. How many ways could this relay team be chosen? 5 factorial? A relay team of 5 teachers. So that's going to be just 15 choose 3, which is, 15 choose 5, which is 15 factorial over 15 minus 5 factorial, which is 10 factorial, 5 factorial. 15 factorial, 10 factorial. A is the answer. 2 cards are drawn from a pack of 5 cards numbered 1, 2, 3, 4, 5. What is the probability that the product of 2 numbers is prime? Probability that the product of the 2 numbers is prime. So 2 cards are drawn from a pack of 5 cards numbered 1, 2, 3. So 2 cards are drawn, right? So we could go with 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. The product of the 2. What is the probability that the product of the 2 numbers is prime? So this is product here, right? So I'm just going to put in the product of the numbers that are prime, which is 1 by 1, which is, actually I'll go put in all. 1, 2, 3, 4, 5, 2, 4, 6, 8, 10, 3, 6, 9, 12, 15, 4, 8, 12, 16, 20, 5, 25, 125, 10, 15, 20, and 25. Let me check and see which numbers are prime. Prime, 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 prime. 1, 2, 3, 4, 5, 6 prime numbers, right? And we have 25. So 6 out of the 25. Okay, so I see what's going on here. We cannot recount a prime number. All right? So since we cannot recount a prime number, this question has an error. Think about it, right? The product of the numbers is in this particular sample space here, right? That is the product of the numbers on the cards. If we are not going to count repeated numbers, meaning if the product is 2, we only count in that once. I cannot do that for all. So initially, the total number of possible outcomes would have been 25. But because we cannot count the total number of possible outcomes, because we have repeated ones, the total number of possible outcomes will not be 25. So let me see what the total number of possible outcomes going to be. All right, so let me just cross off all the repeats, or let me cross off all the repeats, right? I'll cross it off lightly. So this is a repeat, this is a repeat, this is a repeat, this is a repeat. So 2, 3, 4, 5, 2, 3, 4, 5. We can't repeat 4. How much 6s do we have? We could only have 1 6. We could only have 1 8, and we could only have 1 10. We could only have 1 12 and 1 15. Right? We could only have 1 20. So we have 1 2 3 4 5 6 8 10 9 12 15 16 20 25. So that is 5 6 7 8 9 10 11 12 13 14 possible outcomes. So the answer for this could be 3 out of the 14, but that is not option there. All right, so what I think the question, the answers reflecting, not counting the repeated primes, which was going to be 3, but still counting all the total number of possible outcomes, which is going to be the 25. All right, so because of that, do not leave any question unanswered. We will put the 3 over 25 here, noting that this has an error. Cool? The planes represented by the equations. All right, so when you see things like this, you're checking to see if they're parallel. So are these planes parallel to each other? 2x, to get x, I had to divide by 2, right? So it's the first and the second equation is not parallel. To get 2x, I had to, well, to get 2y, I had to multiply, well, minus 2y, I had to multiply by minus 2. So none of these things are parallel to each other. So these will have a unique solution. So 3 will be our answer for sure. And they are not parallel. So 2 and 3. So 2 and 3 is going to give me C. The number of possible values of x which satisfies the equation. So this is the repeat question. If I actually no. Once you have one pair of parallel lines, then it has no solutions. All right. So let me check and see. First and second are multiplying by 2. So these two alone are parallel. So it has no solutions. If the determinant of m is equal to 22, then m is going to A is going to be, so let me go ahead and calculate the determinant. It's going to be 2 multiplied by 1 by 2 is 2. Take away negative 4. So 2 plus 4 is 6. Take away minus 5 to give me plus 5. 1 2 is 2. Take away minus 2a is going to be plus 2a. And then the last one is going to be plus 6 into 2 take away a is equal to 22. So let me see what we could cancel out, right? 12 plus 10 is 22. So the 22 on this side cancels with the 22 on that side, and I go remain with 10a plus 12 minus 6a is equal to 0. 10 take away 6 is 4a is equal to minus 12, and a is minus 3. If the auxiliary equation for a homogeneous second order differential equation with real constant coefficients is given by that, then the general solution of the differential equation may be given by. Alright, let me solve this equation and see what we get. More than likely this is gonna be complex roots, right? So we had, oh god, we gotta get what the, actually we don't have to get what the complex roots is, but let me just verify it is complex. So solving the auxiliary equation, 1 6 and 50. Yes, we are getting complex roots because of this xy on top here, right? In the little corner. Let me show you. Big it up a little bit. See this xy here on this calculator? That means we are in the complex category of the calculator, or the complex function of the calculator. So it's complex. So for complex roots, we know that how the general solution is going to be y is equal to e to the m1x multiplied by a cos m2x plus b sine m2x. So which one gives us this? The only one that gives us this is part D. A suitable integrating factor. So the same mistake I made in the last year, I'm not going to make it this year. It's going to be e to the integral of 2 over x dx, which is going to be 2x to the minus 1. When I do integrating, well, this is going to be 2 ln modulus of x. Move this on top, which is ln x squared. So e to the ln x squared, e and the ln cancels off, and x squared is going to be my integrating factor. Given that y is equal to pi on 4, x is equal to a half, the particular solution of dy dx, which is equal to 2x cos squared y, is 2x. We had to separate these variables now, right? Dy over cos squared y is 2x dx. So this is, when I'm integrating cos squared is the same as integrating sec squared y, which is tan y, is equal to 2x squared on 2, which is going to give me x squared plus c. Y is pi on 4. Tan of pi on 4 is 1. And x is a half. So we get in 1 here. Bring the half across, we get minus a quarter. So we get in 3/4 is equal to c. So tan y is x squared plus 3/4. The answer is A. And lastly, item 45 refers to the matrix M below. M is this the cofactor of the element 3 in M. So this is the element 3 here. So we cancel off here and here. I know that this cofactor is going to be positive. So these two is out of the question. 1, 0, 4, 5. The answer is C. And that's it for 2019.